Hello everyone, today we'll be talking about the minimum stopping distance. This topic is super important for the traffic design and the traffic safety. So as usual, take out your notebook and pen, and wherever you require, you may pause the video for making your notes. In this video, at the end you'll get one checkpoint and its solution, and we'll take two good questions to understand the depth of the topic. Okay, so let's begin. The minimum stopping distance can be understood very well if we deal it in two separate parts, two separate time intervals, namely the reaction time and the braking period. What is the reaction time? Can you answer? Actually, whenever there is a situation, we take some time to respond, and that time is known as the reaction time. Let me elaborate it. Look at this diagram. You are speeding at 200 km per hour, and then suddenly you see three people on the road, a kid, a young lady and grandmother. You will hit at what? Answer it quick.
Your speed is 200 km per hour. You see three people crossing the road. You will hit at what?
The correct answer is you will hit at the brake pedal. You took some time in thinking. That time is your reaction time. Okay. So for good drivers or the pilots of the aircrafts, the reaction time should be less or should be great? For good pilots or the drivers, the reaction time should be less. Okay, let me take one example. Suppose my reaction time is 0.5 second and my wife's reaction time is 0.2 second. Who is smart? Obvious answer, wife is smart. You'll understand this logic, although it will take some time. Anyways, so reaction time begins when the driver decides to hit the brakes, and it ends when the foot of the driver touches the brake pedal. During the reaction time, the speed of the vehicle is constant. So distance traveled will be equal to u into t, where u is the speed of the vehicle and t is the reaction time. Okay. And during this period, the acceleration will remain 0. Done. Now let's go for the braking period. Braking period is that period during which the vehicle is slowing down and then finally coming to stop. The direction of acceleration and velocity vector, they are opposite to each other. So we can use third equation of the motion if the acceleration of the car is assumed to be constant. Using the third equation, we'll get the braking distance is equal to u square by 2a. This is an important formula. The braking distance depends on the speed of the car as well as the braking capacity. Now, if you look carefully at this formula, if the speed is doubled, what will happen to the braking distance? Think about it, keeping all other parameters same. Then braking distance will become 4 times. So the faster a vehicle is moving, it will require more stopping distance, more braking distance. Understand? This is the logic that nearby the schools or the universities or the hospitals, they put the speed limit, drive slow. Slower you drive, the stopping distance will be less. Getting it? So in total, the minimum stopping distance depends on 3 important parameters. Number 1 is the reaction time. Number 2 is the speed of the car. And number 3 is the braking capacity or the retardation of the car. Getting the idea? You may note down all these parts of the theory, then we'll be taking 2 good questions. Okay. Here you can see the first interesting question. I request you to pause here and give it a try, and then I'll be explaining all the details. Okay, I hope you are done with your calculations. So I'm starting the solution here. In the kinematics, we had the talk, we had the tips that in order to solve the questions, first we should draw the diagram, we should imagine the situation. So that we are doing here. This is the moment t is equal to 0, and let's say your car is at x is equal to 0. At this moment, the velocity of the car is 20 meter per second in the forward direction. Done. And the reaction time is given as 0.5 second. So let's say this is the moment t is equal to 0.5 second, and here the x will become 10 meter. How? We know that distance is equal to speed into time. So how much is this distance? Speed was 20 and time available is half second. So that will give you this data. Okay. In this time interval, the speed of the car is constant. Now at t is equal to 0.5 second, the brakes are being applied. The car will retard and its acceleration is given as constant. We are choosing this direction to be positive and this to be negative. Since acceleration is constant, we can use the equations of motion. So let's say somewhere here the car stops. This time I don't know. So from here to here, let's say we consider the moment the car is stopping. This time interval is capital T. And this location X we want to determine. I am doing the calculation. For this computation, we can use the third equation of the motion. The final velocity of the car is 0. The initial velocity is 20 meter per second and acceleration is 10 meter per second square in the backward direction. So let us use the third equation of motion. What we should write? 0 square is equal to 20 square plus 2 into acceleration is minus 10 and let's say this distance is s. So s comes out to be 20 square divided by 20. Is it okay? Answer is 20 meter. Now up to here the car has traveled 10 meter and in this time interval it is traveling 20 meter. So this x coordinate will be actually equal to 30 meter. Now we can easily answer the questions. The first question was asking, is it the lucky night or the last night for the deer? Answer is simple. The deer is yet 5 meter away from the car. So it is safe. So it is the lucky night for the deer. Second question is asking, how much far away is the deer from the car? So that answer is pretty simple. Deer is 5 meter far away from the car at this moment because this total distance was given as 35 meter. Done? Okay. Next question. If someone asks you this moment of time, how much is this moment of time? That also we can calculate. Now for this computation, I'll be using the first equation of the motion. V is equal to u plus at. Final velocity is 0. U is 20 and the acceleration was in this direction. So minus 10 and this time interval was taken as capital T. So computing this T comes out to be 2 seconds. Up to here the moment of time was 0.5 second. Then this time interval is 2 seconds. So here T should come out to be 2.5 second. So from this moment at T is equal to 2.5 second, the car will come to a stop. Getting it? Next question was asking, how much is the distance traveled by the car in the time interval of T is equal to 0 to T is equal to 3 seconds. Looking at this diagram, we can easily tell T is equal to 2.5 second, the car got stopped. Okay. So if you look at T is equal to 3 second time interval, car is yet stationary. Since car is yet stationary, this is the distance traveled. Means your answer should be equal to 30 meter. Getting the idea? Distance traveled by the car in the time interval 0 to 3 second will be 30 meter only. Okay. Now there comes the last part of the question. What could be the maximum speed at which you can drive the car and yet it is the lucky night for the deer? Can you think how to operate the last part of this question, the fourth part? Actually, computation is simple. I'll do that here. You just pay attention for the fourth part. Suppose the maximum speed of the car is u. Then for the time interval 0.5 second, car will keep on moving with that speed only. So how much distance the car will travel? 0.5 u. Okay. And then with the speed u, it will travel here some braking distance. Formula for the braking distance we already know, u square by 2a. So u square by 2 and acceleration here had the magnitude 10. Clear? This is the total distance. This is the distance traveled during the reaction time. This is the braking distance and it gives you the minimum stopping distance. For the lucky night, this minimum stopping distance should be how much? 35 meter. Put here 35. Now only unknown here is u. It's a quadratic equation and you can simplify it. Moment you simplify it, you'll get the u is equal to 21.9258 meter per second, or you can write it approximately 22 meter per second. Getting it? So this is all about this question. You can note down the solutions, and if you have any doubt, you can fire up the chat box. I'll reply. Then we'll take up the next question. Here is another interesting question, and since I have solved the previous question in the detail, so I request you to pause the video here and try to solve this question yourself and then post your answers in comment box. Okay, I hope you are done with your calculations. So I'm starting the solution here. Before I start the solution, if you read the question carefully, can you tell me the full name of Vijay and the name of the bank? You might be knowing these things. Okay, as usual, using the tips from the previous lecture, I'll draw the diagram first. T is equal to 0. The Vijay is here at x is equal to 0. And the reaction time of the Vijay is 0.6 second. So this x coordinate I can determine using the formula distance is equal to speed into time, because during the reaction time the speed of the car will remain constant. How much is the speed of the car? 50 meter per second. How much is the time interval available? 0.6 second. Doing this computation will get 30 meter. Okay, fine. Now at t is equal to 0.6 second, the brakes are applied, and after this the car slows down at the constant rate. Now we need to determine that Vijay is inside the jail or outside the jail. Calculation is simple. Let's say the car covers up some distance here. That distance we don't know. I'll call that distance as S. Okay. For calculating this S, we can use which equation of the motion? Simple, you know. We can use the third equation. So 0 square. Final speed of the car will become 0. Initial speed was 50. Plus 2 into acceleration is minus 10, because this direction has been taken positive, this has been taken as negative. Velocity and acceleration were opposite, and let's say this is S. So S comes out to be 2500 divided by 20, which gives you S is equal to 125 meter. This distance was 30 meter, this distance is 125 meter. Vijay has actually traveled a total distance of 155 meter, which is greater than the 150 meter distance. Means Vijay's car has crossed the nails. So the tire will burst out and the cops will catch the Vijay. So Vijay is in the jail. Clear? Simple and easy question. Note it down, then we'll go further. Since you are enjoying the questions, I would like to take one last question. So if you wish, you may pause here and give it a try yourself. I hope you are done with your calculations. So I am starting the solution here. As usual, we'll draw a diagram. T is equal to 0. Car is at x is equal to 0. Okay. And since the reaction time is 0.5 second, so x coordinate here will be 10 meter. How? We know that during the reaction time, the speed is constant. So the distance will be equal to that speed into time. And speed is 20 meter per second. Time is 0.5 second. So this answer comes out to be 10 meter. Okay. Now, the train will reach to the crossing in how much time interval? Speed of train is 30 meter per second and it has to travel 60 meter. So it will take actually 2 seconds. And in that available window of the 2 seconds, I should cross the crossing. We are assuming everything to be a particle here. You should not bother about the size of the car or the train. Okay. So out of that 2-second available window, I have consumed here 0.5 second. So how much is the remaining time available for me to cross the crossing? The remaining time available is 1.5 second. And in 1.5 second, how much distance I have to travel? Total distance up to the crossing was 45 meter. Out of 45 meter, I have traveled here 10 meter. So the available distance is 35 meter for this interval. Okay. I'm using here the second equation of motion. Displacement is 35 is equal to, the speed is 20, time is 1.5 plus half, acceleration is unknown, time is 1.5 second. Is it okay? Let's do the computation. Here only unknown is A. So when we compute it, it will come out to be 4.44 meter per second square. So if I drive my car with this acceleration, or my car has the acceleration equal or greater than this, I'll be able to deliver this lecture and the upcoming lectures. Okay. I hope you are enjoying the things. Note it down, and then we'll be taking up a checkpoint. After that, I'll give you the idea how to measure the reaction time. You can do it at your home. Here is a simple practical to measure your reaction time. You can do it at your home. Take a simple ruler or the scale. Let's say your friend is holding the top of that scale and your fingers are here. Okay. Now you mark the position where you can see the digits of the scale, that this number of the scale is in between your fingers. Now ask your friend to release that scale, and you have to quickly stop the scale as quick as you can. The moment your friend releases the scale, you should try to stop the scale. Then you will see a new number in between your fingers. The new number and the old number, using these two numbers, you can find how much distance the scale has traveled in between your fingers. And for that distance, we can do the calculation using the second equation of motion. S is equal to ut plus half at square. Okay. Let's say the distance is s only, u of the scale was 0, plus acceleration is acceleration due to gravity, which we take as g, and then t square. So from here t comes out to be root of 2s by g. Usually the value of acceleration due to gravity is 9.8 meter per second square, or for calculation purpose you can take it to be 10 meter per second square also. So practically you can measure this s, okay, and then you already know g, it will give your reaction time. I urge you to determine your reaction time and post it in the comment box. Let's see who is the smarter one. You can try it with your friends. Okay. So I hope you are enjoying the learning. Here is an interesting challenge. You can see this 500 rupee note, and I am going to drop it. I am going to release it. And can you catch it? You can try this experiment at your home, and the results are amazing. So pay attention here. I am holding this corner of the note, and your friend should put the fingers at this position. Moment you release the note, your friend should try to catch it. What do you think? Your friend will be successful in catching this or not? Pause the video here and post your answer in comment box quickly. Okay, I am going to release it. Give it a try. Oh, it's not successful. Let us try it once more. I have the another note of 500 rupee. This time ask your friend to put the fingers here at the middle of the note and then give it a try again. Now what is your answer? Again pause the video here and post it in comment box. Okay, now we are starting the experiment. I am dropping it. Again, your friend is unable to grab the note. Now, can you answer why it happens? The answer lies in this video. The logic lies in this video. I am awaiting for your answers. And another interesting question. If you repeat the same experiment with a bunch of 500 rupee notes, will your friend be able or successful to grab that bunch like this? Give it a try and then post your opinion, post your answers, post your experience in the comment box. I'm waiting for that. Stay awesome. Take care. Happy learning.